The image of a map that most people carry in their minds is that of an ordnance survey sheet or of a road atlas of some kind, printed in a number of colours. These colours are used for aesthetic and practical purposes to give a pleasing design and as an aid to interpreting the information contained on the map. The use of colours as such in a map occurs only at the first and last stages of the map production process. And this video will show how the cartographer's design, drafted or only envisaged in colour, is transformed by using standard black and white drawing or photographic materials through the various stages in the map-making process to the final coloured, printed version. The most commonly used method for printing coloured maps is offset lithography. This makes use of a metal or plastic printing plate attached to a rotating cylinder which transfers the image on the plate to the paper via an intermediate impression cylinder, hence the word offset. Rollers apply an even covering of coloured printing ink to the printing plate, as the image on the plate itself is not coloured. The colour itself exists only as ink used in the printed impression. One colour can therefore be printed over another, and use is made of this facility, as we shall see later. It follows from this that one printing plate must be prepared for each colour to be printed on the finished map, and that the image for each of these plates is prepared in the same way, regardless of what colour each is to be printed. The role of the cartographer, therefore, is to formulate a design for the finished coloured map and to produce a set of drawn and/or photographic materials, each of which will contain the image for one of the printed colours. In other words, a set of print-ready colour separations. This video sets out the basic principles and materials involved in this, together with some of the methods used in the sequence of stages to prepare materials ready for plate making. In order to establish the form of this end product, it is necessary to examine briefly how the image on a pre-sensitized printing plate is made. This is normally done in one of three ways. 1. By reflected light from flat copy in positive form. In other words, a black image on opaque white material. 2. By transmitted light through a transparent positive, for example, a black image on drawing or photographic film. 3. By transmitted light through a film negative, in other words, a window image in an opaque material. An essential property of all these forms of plate-making material is that of high contrast between the image and the background. The black image of the positive forms must be dense and opaque in a clear surround, and vice versa for a film negative. This property is particularly important when a transmitted light process is used. A second essential property in transmitted light systems is that the image must be in contact with the new image surface of the plate. If not, the widths of lines on the image will increase in the case of a negative, or with a positive become thinner, owing to the light spreading through the thickness of the backing material. It is convenient to relate our examples to negative working plates, as this will give a photographically orthodox sequence leading to a correct reading image on the plate, as required in offset lithography. In other words, printing via a blanket roller. As a sample, we shall use a map of modest size for printing in 4 colours. It will serve to demonstrate the system involved in making colour separations, as the principles shown hold good for any map to be printed in colour, however complex. We saw earlier that colour is introduced only at the printing stage in the form of ink applied to the plate. We also saw that each plate carries the image for one specific colour. This means, of course, that any single plate can be printed in any chosen colour. Consider the simplest case of a part of a map to be printed in, say, black for the border and title. As the materials used are thin and the images generally very small, we can demonstrate these processes more effectively by using blocks which represent greatly enlarged parts of the materials used. The negative is placed against the light-sensitive surface of the plate, which is then exposed and developed. Here, the image on the contact side of the negative is in reverse. This results from the drawn positive image used to produce the negative being right or forward reading. Hence, a contact process will reverse this as the working faces come together. This same negative can be used to show that two plates can be made from one negative if, for example, a black border with a red name were required. By masking or blocking out the name, a plate could be made for the border. Then, by masking out the border, a second plate for printing in red is made. This method is clearly more economical than making a different negative for each colour, but is only feasible where the images are well spaced out and separated. If, for instance, crossing or joining lines of different colours are required, it is easier and more economical of time to prepare a negative for each set of coloured lines. Similarly, separate negatives are essential where a coloured area is bounded by a different coloured line. For this purpose, cartographers have at their disposal several different types of material. Whereas you have so far seen only an orthodox photographic negative, scribing and strip mask materials have the same properties, allowing a set of line negatives to be made directly without a preliminary drawing. These come in several forms, as can be seen from the examples shown here. Cut and strip material for areas, and, for line work, scribing materials in any one of several colours. The fit or register between negatives for different printing colours must be considered. For accuracy of register between colour components, and to enable register to be maintained in darkroom conditions, a system of punch registration involving studs or pins is used. The one shown is of the simplest form, making use of two punched holes along one edge of the material. Studs or pins are then set into the punched holes of both the current component and the next one to be processed. The new material must of course be punched before the processing takes place. The printer also may have punch registration facilities for the plate making stage, which would enable this system to be used when making the plates. Normally, the compilation or first design draft would be punched before any further stages could be carried out, then processed onto the scribes to make a key. But it is feasible to tape the compilation to the first scribed or drawn sheet, which must then be punched before any subsequent processing. Note that the position of the work relative to the studs is the crucial factor, not the shape or any particular edge of the material. For our two differently coloured line requirements then, we need the compilation, one scribe for the black border, and one scribe for the blue coast, all studded. Density of image is automatic in a scribed line, but we must also allow for contact working. Therefore the scribes, which are negatives, must be prepared in reverse. These could then be used for plate making, giving a contact, forward-reading image. To make a negative of an area of any colour, it is simply a matter of using a photographically opaque strip mask, such as cut and strip, where the opaque film is simply removed to produce a clear window of the required area, having cut through the membrane along the boundary of the area. Again, as a negative, this shape must be cut out in reverse, working from the compilation. Although this is a satisfactory method for any area in isolation, the means exist to strip out an area whose edge is defined by a line, so that an exact fit of the area to the line results. This makes use of a sensitized strip mask. A scribed line is exposed with UV light onto the strip mask. etching with the appropriate solution physically removes the membrane to form the boundary. It is then a simple matter to remove the remaining mask within the area. If necessary, 2 or more scribes may be exposed in succession. The resulting window includes the width of the line, but in practice this would not be required if the line is to be printed in a colour different from the colour of the area. So a further stage is introduced to remove the width of the line from the total area to be stripped. Having exposed the scribe to the strip mask and etched out the line is then filled with an opaque liquid, in this example, mask coat. When this is dry, the area can be stripped out, leaving a ring of mask coat round the edge corresponding to the exact thickness of the line. This results in 2 negatives, one for the line, the other for the area, and each can be printed in a different colour. Now, if contact is maintained in processing a negative strip mask from a scribe, the area mask will be out of contact, as it must be stripped from a forward-reading image. This means that the area limits will spread slightly at the next processing stage, though this will in fact be within acceptable limits. By spreading slightly into the line, it avoids the possibility of a white gap between line and area. If this is unacceptable in a particular job, a duplicate negative can be made, which would have the effect of producing a negative which is reverse reading on its contact or emulsion side. Printing from the area negative would result in areas of solid colour. This can lead to practical problems in printing if the areas are large. Furthermore, many people find large masses of strident colour visually displeasing, and there may be a specific need to use different strengths of a single colour, for example, when a map has to show a hierarchical data set. This would mean a very high printing cost if, for instance, dark blue, medium blue and light blue inks were used, each needing a separate plate, of course, and each needing an extra run through the machine. This grading can be achieved using only one colour by reducing the strength of the colour as required by screening. This has the effect of completely removing a finite, predetermined amount of the area by using a photographic screen. The printed sample shows the finished effect, where the lighter blue is made up of printed lines or dots, interspaced with the white of the paper. The colour of the printing ink is the same as that used for the line in solid colour. These sections of screens, one of lines and one of dots, show how the strengths of a colour can be determined. In this sample, black. The percentages which describe their strengths represent the percentage of the total area which the dot or line image occupies. This can be seen more clearly in this enlarged version, part of an 80% line screen, where the black image covers 80% of the total area. This enlarged section also serves to demonstrate that the percentage system of describing a screen's strength holds good however coarse the screen is. A means also exists to describe the coarseness of a screen by specifying the number of lines or dots per inch or centimetre. This example shows the fine and coarse limits generally acceptable in map work for reproduction at drawing size. Many intermediate values are available, and the choice of strength, specified by percentage, and choice of grain, specified by number of lines per inch or centimetre, would be determined by factors of design requirements and functional considerations at the printing stage, in particular, the grain limitations of the printing plates to be used. Using the enlarged blocks, we can now illustrate how these screens are used to break down areas of what would otherwise be solid masses of colour, existing at this stage as a window in a negative. The screen is introduced between the area negative and the new film and then exposed. The working film must be fitted by studs, but not the screen. The new image will of course be a reciprocal value of the screen actually inserted and be in the form of a positive, having been contacted from a negative mask. For example, to achieve a value of 70%, a 30% screen would be used. A subsequent contact negative would have to be made from this for plate making. The photolithographic exposures for this type of work need to be carried out on a contact frame of a suitable size, with stud register to hold the fit between successive stages, and with a vacuum back to suck all the pieces of film firmly in contact while the exposure is made. This ensures perfect fit and prevents the degradation of fine dot or line images in the screen, which occurs when the image surfaces are not in contact. As an alternative, a screen can be introduced when the plate is made. Here the screen would be laid between the area mask and the plate during exposure. In map work, however, it is normal to supply the printer with ready screened negatives or positives. Our screened example has shown how one area is tinted. The same system can be used several times to introduce several strengths of any one colour. If we consider the blue areas in our sample map, we require solid, or 100% colour for the coastline, a strength of 30% for the sea filling, and initially 60% in the land areas. We can build up this variety on one sheet of new film by a series of exposures as follows. First, the line negative scribe for the solid. Then a mask of the sea with the 40% screen, and then the mask for the land and a 70% screen. In this way, we can build up a succession of exposures prior to development. In this instance, dot screens at 65 lines per inch are being used. The resultant contact positive combines these strengths, all to be printed in blue, and is known as a combined positive. The combined positive, then, has brought together all the components to be printed in one colour, blue in our sample, so that all blue elements can be printed from one plate. A similar sequence would be followed to bring together all the elements of other colours required in the design. And it is by overprinting one colour on top of another in different areas that a wide range of hues can be produced, each capable of being precisely specified by referring to the percentage strengths of the component colours. Thus, in our sample map, we can see the changes brought about by printing the red and the yellow plates, superimposing a selection of tints to give green, for example, from a yellow and blue combination. The angles of the screens introduced for overprinted colours must follow certain rules, since if random angles are used, secondary patterns are produced, known as moiré patterns. These can vary from being small nuisances to gross distortions. They can be demonstrated by rotating two screens together, and they must obviously be avoided, otherwise the sort of effect shown in this sample may be produced. In order to formulate a design, sample colour charts can be made or are commercially available. This one shows the three basic process colours, plus black, as they appear in various percentage tints. The overprinted black names and symbols demonstrate overprinted legibility. The next shows the results of overprinting the three process colours using increments of 20%. By referring to a chart of this type, the cartographer can define precisely any required colour, specifying the component colours and their strengths by percentages, which can then be translated using the processes and stages we have described to produce final film copies for plate making. The object being to produce one film copy for each colour to be printed, and with each colour sequence, one mask or scribe for each strength of colour that is required. Our sample map has introduced these processes in a very simple form, but a close look at any of our first samples will give some idea of the complexities which can be involved in preparing material for more sophisticated productions. It is therefore essential to plan the stages and processes involved between design and plate making before any production stage is commenced. This is done by preparing a flow diagram which will define precisely each stage in the production chain and the type and form of material to be used. It is advisable to start this by considering the end product first and build up the diagram from that. So in our sample, we know that our intention is to produce negatives, one for each colour, for plate making, so-called printer negatives. By working from this last stage, it helps to avoid unproductive material being prepared, which would not lead directly and economically to the final negatives. Thus, we start with our final reverse reading negatives to contact to the plates for forward or right reading images. Prior to that, we generally need a combined positive for each colour, which should contain all the elements required in that colour. This is made from a series of line or area negatives with screening introduced at that stage. The negative used in the combines can take the form of a scribed sheet or masks to fit the line produced from the scribes using pre-sensitized strip masks, and possibly a negative of names and point symbols. These then lead us back to our first stage production components of drawn or scribed sheets, all derived from the first design and compilation. This flow diagram has been built up from our sample blocks, but it would, of course, normally be drawn. It is essential to include every component, suitably annotated, to define it as a positive or negative, whether film or mask, forward or reverse reading, screen strengths, etc. Liaison with the printer is also essential to establish basic requirements, such as the finest screen reproducible on the printing plates, what guide and register marks are required, the limits of the printing area, less than a nominal paper size of course, and in particular, whether positives or negatives are to be supplied for plate making. If positive working plates are to be used, the final positives would have to be in contact with the plate surface. This would totally reverse the sequence of reverse negative, forward positive images we have considered in our example, and would therefore require the flow diagram to follow a different path entirely. But you can now work that out for yourselves.